lesson is going to be on writing equations with piecewise functions. So we're given a graph for a piecewise function, and we're going to turn it into the equations for each piece. So let's start off by looking at how many pieces we have here. So we have, here's one piece, this line. This line is the second piece. We know this is not an absolute value because it's not symmetric on both sides. For it to be absolute value, it would look like a V, and they would have to be going, they would have to have the same slope. And this one clearly is not symmetric, so this is two different lines. This point right here is going to be our third equation, and then this line is going to be our fourth. So we're going to have four different pieces of this function. So in my f of x, I'm going to draw a bracket, and I'm going to have four different pieces for this function. So let's start off with the first one. So we know the first one is going to be a line. So if it's linear, it's going to be in the form mx plus b. So to find our slope, what we're going to need to do is find our rise over run. So m is rise over run. So what we have to do is pick one point. So let's say we're starting at this point right here. And then find rise over run toward the next point that's exactly on a line. So this one, not exactly, not exactly, not exactly. Here's the first point that it crosses the line exactly, both horizontally and vertically. So now we can start at this point and count here. So rise is 1, 2, 3, 4. And our run is 1, 2, 3, 4, 5. So if it goes up 4 to the right 5, our slope is going to be 4 over 5. And for our b, we know our b is just our y-intercept, which in this case we can see our y-intercept. It is exactly right there. So if it crosses the line at positive 5, my b is positive 5. So my equation, my first equation, is just going to be 4/5 x plus 5. So that's the equation for a line. Now the part where we have to make it piecewise is we only want one piece of this line. It's not the whole graph. We want it to be in between these two numbers right here. So we wanted to start at -10 and stop at, again, we're looking at our x values because we're looking at the domain, so 0, not 5, 0. So we're going from -10 to 0. That's the part of this graph we want. So -10, we want our x to be greater than -10. This is a closed point, so we're going to have an equal sign underneath it. And also we want it to be, we want x to be less than 0. And so since there's no hole there, we're also going to put a closed point, so we're just going to put equal to because there's no hole there. So we're going to include the 0. So from -10 to 0, our graph looks like this line. Let's look at number 2 now. Number 2, similar idea, still a line, so we're going to do linear mx plus b. Let's find our slope. So rise over run. Let's take this point right here. Find our next point that's exactly on the line, which we can use this one right here. Count rise over run, so this is going 1, 2, down 2, right 1. So if it's down, it's going to be a -2. -2 over 1 gives me a slope of -2. My b value is still my y-intercept. And in this case, our y-intercept is also 5. So my equation is going to be -2x plus 5. Now let's look at this graph. What do we want our domain to be? We want it to be in between these two numbers right here. So 0, and this is ending at 3. So it's going to be between 0 and 3. For our 0, we already included 0 in this graph. We said it was a part of the first one, so it's not going to be part of our second one. For this one right here, this is an open circle, so if it's open, we're also going to not include the 3, so there's no equal sign under either of these. Okay, let's look at our third one. Our third one is simple because it's just 1 point, so we just need to write the y value, which is 2. And our x value is simple too. There's only one x value. It is x is equal to 3. For our fourth one, this is again a linear function. This is a straight horizontal line. So a horizontal line is just y equals 4 because the slope is 0. And then let's look again at the domain. We want it to go from 3 on until infinity. So we just want our x to be greater than 3. No equal sign because it is open circle. So x is greater than 3, so it's going on from 3 until infinity. Okay. Let's look at our second example now. So this is where it gets a little bit more complicated. We have, this is the first section of our graph, number 1. We have a second section right here and the third one. So we only have 3 sections of this graph, 3 pieces. So we know that the first one here is clearly another linear function, it's a line. So again, let's find our rise over run. So let's pick a point. Pick another point exactly on the line. There isn't one until this one right here. So we're going to be finding rise over run this direction. So our rise is 1, 2, 3, 4, 5, 6, 7 down. We're counting the spaces. 7 down. 1, 2, 3, 4, 5, 6, 7, 8 to the right. So because it's down, it's going to be a negative 7 over 8. So our rise is our slope is negative 7 over 8. We still have to find our b. So b is a little bit trickier for this one because you cannot see what your y-intercept is. And even if you were to extend it, it would be a fraction. It's not going to hit exactly at a whole number. So we're going to have to solve for our y-intercept. So we know our equation is in the form y equals mx plus b. We know that our slope, our m, is negative 7 over 8. So we have to solve for b. In order to do that, we just need 1 point. We need an x and a y to plug in to solve for our b value. So for our x value, or let's just pick a point. We can pick this point right here, negative 2, comma, negative 7. And this will work for any point on the graph. So negative 2, negative 7, this is what we're going to plug into our x and our y. So our y value is negative 7, our x value is negative 2. And so we have negative 7 equals, multiply across. This is the same thing as negative 2 over 1. So this is positive 14 over 8 plus b. And to solve for b now, we're just going to subtract 14 over 8 for both sides. And so our b is equal to, we have negative 7 minus 14 over 8. Which we can simplify. So 14 over 8 is 7 over 4. And to get this to have the same denominator, we're just going to multiply both of these by 4. So this is going to become negative 28 over 4 minus 7 over 4. And negative 28 minus 7 gives us negative 35 over 4. And so this is our value for b. So our equation becomes negative 7 over 8x minus 35 over 4. This is my value for b. That was my value for m. Okay, let's look at our domain now. So for this one, we wanted to start at negative infinity, stop at negative 2. So we want our x's to be less than negative 2. Because this is a closed circle, we're going to put an equal sign underneath it. So that's our domain for this one. Okay, let's look at our number 2 equation now. This one, let's look at the shape of it. It's clearly in the shape of a parabola, so that means it's quadratic, which is an x squared function. Looking at the shift, it's moved from the origin 2 up. So we know it's moved 2 up. And looking at our parent function, which is 0, 0, 1, 1, 2, 4, you can already tell that it's been flipped across the x-axis. So there's an x-axis reflection. And even if you did flip it across the x-axis, so it would look like this now. So if it was 1, 1, 2, 4, it would be on these points, but instead it's here and here, here and here. So starting at the origin, it's going 1 over, 2 down, 2 over, 1, 2, 3, 4, 5, 6, 7, 8 down. So instead of going 1, 1, 2, 4, now it's going 1, 2, to 8. So what has happened to my points? Look at your y values, they've been multiplied by 2. So if your y values have been multiplied by 2, this is a vertical stretch by 2. So now we're going to turn all these into an equation. So we know that we have an x squared. X-axis reflection means there's a negative y. Vertical stretch means there's a 2 in front outside of the parentheses. And then up to plus 2 is also outside the parentheses. So this is my equation for number 2. And let's look at the domain again. So it's between these two right here. So it starts at -1, goes to 2. And we want it to be open circle at -1, so no line. Closed circle at 2, so we're going to put a line underneath that one. Okay, last function we have, number 3. This one is opening out, not up or down, so this is a square root function. And the starting point from the origin has clearly been shifted 2 to the right, and 1, 2, 3, 4, 5, 6 down. And if this is my starting point, my parent function is 1, 1, 4, 2. So it looks like it's exactly on it. So nothing else has happened. It hasn't been reflected. It hasn't been stretched. It's just these two shifts right here. So if it's gone 2 to the right, we're going to say -2 inside, 6 down, -6 on the outside. This is my function for number 3. And again, let's look at the domain. We just want it to be from x equals 2, so this value right here, and all the way to infinity. So we want x to be greater than 2. And since we already have a closed point at the 2, we put the equal sign in the second equation. Since we've included it for the second equation, we don't need to include it for the third. So this is my final answer, and I'm done with this problem.